Hello, my name is Andrew Geraci, and today I will be teaching you about counting sort. You probably have many questions, such as, who are you, why are you here, and what is counting sort? I can answer one of those questions. Counting sort is a sorting algorithm in computer science. There are many different types of sorting algorithms, but today we will only be talking about counting sort. Counting sort takes an array input, which we can see here in A, the input list. You can also use a second input as the length of the array if you choose to. Next, counting sort determines the frequency of an element in the array, which we see here in C, the counting array. Then it uses the frequency to determine the final index of the element, which we see here in the final S sorted sequence, which will be your return value. Counting sort finds the maximum largest element in the array, which is shown here, where we have the input array of 4228331. The largest value in this array is 8, so that will be our max. It creates a new array with size max plus 1, which we see here. This is our count array. It starts at index 0 and ends at index 8. This will all be initialized to 0, but we've skipped that step and stored the count of each element at its index, which we see at 0, there are 0 occurrences of 0. There is 1 occurrence of 1, 2 occurrences of 2, 2 occurrences of 3, 1 occurrence of 4, 0 for 5, 0 for 6, 0 for 7, and 1 for 8, our max. Next, we need to add the elements to create a cumulative sum and store it in the count array. So this is the same example as the last slide, and we see here that the numbers have been added together for each element, and it's been created a cumulative sum. Next, we have to find the element in the count array of the index from the input array. Now we see at index 0 of the input array is the element 4. And at index 4 in the count array, the element is 6. Then you must place the element in the original, place the element from the input array at index of the element in the count array minus 1. So at index 4 in count array, the element is 6. So in the original array, 4 will be placed at 6 minus 1, which is 5. And that is how you do a counting sort. Congratulations. The running times for counting sort. The worst case is O(n plus k). The average case is also O(n plus k). And the best case is O(n plus k). And this is an example of O(n plus k), where you iterate through n, and then in a separate for loop, not included in the first one, iterate through k. And counting sort is very advantageous because no matter what, you will always have the same running time, O(n plus k). So if you know what you are putting in as an input, you will know the running time of the algorithm. Stability and in place. Is counting sort stable? Well, first, what does stable mean? Stable is when the elements of an array are in the same indexes in the sorted array. So, for example, in this array, the unsorted list, we have 3, 3 prime, and 3 double prime. In the stable array, they will also show up in that order, 3, 3 prime, 3 double prime. However, in an unstable array, they will show up in a different order, 3 prime, 3, 3 double prime. Counting sort is stable, so it will look more like this than it will like this. Is it in place, meaning is only one array used in the whole algorithm? And the answer to that is no. We have multiple arrays because we have the count array that we need to use. When is counting sort used? Counting sort is used when all of the elements in the array are positive integers and the maximum value of the array is relatively small, around less than about 1,000. And you look at this picture of a counting sort and you think this is going to be very, very complicated, but it turns out that counting sort is actually one of the most simple sorting algorithms in computer science. And here we have some code I put into Eclipse to do a counting sort. We go here, we initialize all of our arrays, find the max element, initialize the count array to all zeros, store the count of each element in the count array at their respective indexes, and then we sum them all together to get the cumulative account for each element for each index. And then we find the index of each element and place the elements in the output array. This is creating our sorted array, and then we copy the sorted array into our original input array. And this is the main function with the same array as the example used in the previous slides. And I added a print array method that is not here to print the array. And this is the sorted array. So we go from 4, 2, 2, 8, 3, 3, 1 to 1, 2, 2, 3, 3, 4, 8, which is all in order. And that is how you do a counting sort. You did it. Congratulations. I am so proud. I hope you all had a great time.